How should span be set up optimally on the ASR 9000? DMEs get this kind of question on a very frequent basis. So I'm going to go ahead and try to break this down into 3 basic questions that we're going to answer today. The first one is, how much traffic can the router replicate? Second, is there a specific port on the router that gives me better performance than the other if I have to connect it to a network analyzer? And the third, is there anything I can do, maybe some tips or tricks that I can play with on the router that help me get better performance for span? Before we go any deeper, I want to first cover the different span types. So there's 2 main types. One is the most common, that is the pseudo-wire or ER span, where traffic is sent from the router all the way to a central site, maybe a data center or a NOC site across an MPLS cloud. Is there any consideration there when it comes to performance? Not as much when you compare it with local or remote span, because the basic mechanism of performance is more or less the same. But it's good to know all the details on how this works, so that if you do not have a spare port on the router that is connecting it all the way back to the data center or the NOC site, then how exactly are you going to decide which port to take, right? So do you want to create a specific pseudo-wire or traffic engineering tunnel that is choosing one port over the other that is maybe less loaded? So we're going to go into those things. Now, when you talk about the other type, which is the local or RSPAN, even though it has remote in its name in RSPAN, these 2 techniques are mainly used for local sites where your analyzer is available locally, either directly connected using a laptop or maybe a server sitting on the same side connected via some switches. So in that case, if you have, let's say, a laptop with a gig or 10 gig port today, it's not really going to be a big problem for 5th generation ASICs. That's most of the ASR 9Ks are running today. So I don't even think we need to spend too much time planning that. But if you are talking a few years down the line where maybe laptops have a 100 gig a NIC or a server in the same facility as a 100 gig NIC, now you need to start planning the capacity a little better to be able to get the most performance out of span. Where should I connect the analyzer on the router, or what would be the destination port? Now, at a high level, I'm going to try to answer this in very simple terms, right? So if you have multiple line cards on a chassis, then just choose the line card that has nothing plugged in, or you're not really using it for any traffic. Makes it really easy. You know there's nothing going on. You'll get the best performance. What if you have only one line card on the system, or all the line cards in the system are being used in some way or the other? Well, then try to pick a line card that has a slice or an NP. That's basically a grouping of ports to the same network processor that is unused, or that is least used, I would say. And the same answer carries on if you had, only one NPU-based line card, which today we have only the 400 gig flex in the 5th gen. But if you were in that kind of a scenario, or you again were restricted to only one NP where you could plug in, then just find the NP with the least amount of ports connected to it, that has the least loading, basically. So that's like a high-level guideline on what you should be looking for. How much traffic can the router replicate in terms of mirroring? Now, there is no simple answer for that. There isn't a single number that I can give you that tells you what the performance is like. But it's important to understand what those factors are that determine the performance. And so we're going to go over some scenarios that talk a little bit deeper. But just to give you some idea, it matters what the direction of your mirroring is. If you're doing ingress, you're going to see better performance than egress just because we have more resources in that pipeline. If you're going to calculate the total user data going through the NPU, that's not the only thing that matters. You have to understand that even when you enable port mirroring, all of that mirrored packet is also counting up space in terms of the NPU to fabric and fabric to NPU bandwidth. And it is a feature, just like ACL or QoS, it is another feature that is getting pushed onto the NPU. So it does add some amount of penalty to actually run. Now, apart from this, if you were to compare 2 NPUs with similar data loading, I would look at one NPU that has the least amount of features configured, and also the higher average packet sizes or the frame size going through that NP, because that is going to give you better performance if you just compare and everything else is equal. What else can one do to make mirroring more efficient? So one thing that comes to mind is we mostly capture packets when we're troubleshooting. And if you have a service that is terminating on a subinterface or an EVC, then you just want to span that one EVC or subinterface. So let's say that's a 500 meg circuit coming in on a 100 gig physical port. So now you have 200 times savings in terms of the amount of data that would have been replicated. You're only replicating 500 gig. That's a big saving there. Another thing you could do, especially when you are dealing with profiling a network, right? So you just want to maybe run span for a week, get to know what's going on in your network. Maybe you're running too much TCP versus UDP or so on and so forth. In that case, you probably don't want to capture every single frame running through, but you want to sample. So maybe if you take 1 out of 1,000 or 1 out of 4,000, 1 out of 300 packets, you're sampling at that rate, and only those packets are getting replicated. So that's a massive saving in terms of the resource utilization. Another thing you can do in this kind of a case where you don't need the entire length of the packet. So maybe the average frame size in your network is 700 bytes. And you're okay just capturing the first 350 bytes, right? So just the mainly headers and some amount of the body is all you need. Then that's straight away a 50% saving because you're now capturing 350 bytes per packet versus 700 on an average. And last but not the least is filter traffic, right? So just use ACL. So if you have a specific flow or a few flows that you know are coming from this IP that are UDP or TCP, and you know exactly what you're looking for, create an ACL and apply that to the session. And in that case, you're only capturing what's really needed. Maybe you're down to a few kilobytes or maybe a few megabytes per second. So that gives you the most savings. I'm going to take a few scenarios to explain the calculation part a little better. I'm going to start with the 100 gig port FlexLine card that runs the 5th gen ASIC. It has 5 slices or 5 NPUs that are grouped together in 400 gig ports. What's interesting is the concept I'm going to tell you about here is applicable across all the line cards and across the compact systems like a 9902 or 9903. What's important is to know which are those ports that are getting grouped together in a single slice going to the same NPU and the same fabric chip. So that's basically what's important. We need to push some traffic through first that we need to replicate. So if I connect, let's say, a traffic generator to ports 0 and 1, and just send traffic 100% line rate, so 100 gig going in on port 0 destined to port 1, and 100 gig going in on port 1 destined to port 0, right? So that's 200 gig in, 200 gig out. That's what we're using in a 400 gig NPU. So we still have 50% of the bandwidth and the capacity free. Now, if I want to span, let's say, just the ingress, just the RX on port 0, all right, I want to mirror that. Like I said earlier of the session, that I'm going to look at the NPU that's hardly being used. So in this case, I'll just take the last NPU. That's NPU 4, and the last port 19. Well, there's nothing on that NPU. So I'm just going to plug port 19, 100 gig port, towards the network analyzer. How do you calculate how much traffic is going in and out of the fabric and the NPUs? 200 gig going from NPU to the fabric, because that's the user data. And that 200 is coming back to NPU 0 from the fabric. But because we're replicating what's coming in on port 0, that 100 gig of span traffic is also going to have to be sent on the fabric. So the fabric can send it to NPU 4 out port 19. So now we have 300 gig going from NPU 0 to fab, and from fab 200 gig user traffic and 100 gig span traffic. This should work. You shouldn't see any big issue, especially at IMIX. I don't see any problem here. The next scenario I'm going to take on is basically the same one as scenario 1. The only thing changing here is I'm also going to enable the transmit or the egress direction on that port to be spanned on port 0. So now you have the same 200 gig in and out of user traffic, but now there's going to be 100 in and 100 out going to get replicated. So NPU 0 is going to send 200 gig of user traffic to the fab and another 200 gig of mirror traffic to the fab. So basically 400 gig going to the fab. 100% of that is used up now of that slice. And because you have 200 gigs going out, you need to add another port going to the analyzer, another destination port. So here I'm going to take 18 and 19 and then map RX to 18 and TX to 19 and across 2 sessions. So that way you don't want to squeeze your entire 200 gig out a single 100 gig port, you would see link drops there at 50%. We don't want that. So you want to make sure that there's enough capacity on your destination ports to handle what's coming in from the source. If you want to complete how this looks, you have 400 gig going from NPU 0 to fab, from fab 200 gig coming back to NPU 0, that's user traffic. But there's another 200 traffic of mirrored packets that's now going to NPU 4, out ports 18 and 19. We should be able to handle this, except your NPU 0 is now at 100% capacity when it comes to NPU to fab limits. And of course, even the packet processing limit, it's already at 100%. So not recommended to run this, but it's possible to do this. In the next scenario, we're basically going to now add the RX and TX span on port 1 also. So now you have both the ports running user traffic at 200 plus 200, and you also have both directions span on both the ports. And ports 2 and 3 are still not plugged in. So now you have 400 gig of traffic that is being replicated. So you need to have 4 ports on the egress where the destination is going to be. I take ports 16 through 19 on NPU 4. So now you have 400 gig available to be sent out towards the analyzer. But now when you start calculating what happens from NPU 0 to fab, you have 200 gig, the original user data, but you also have 400 gig on top of that that is mirrored, 200 and 200 are being mirrored. So now you have 200 gig of user traffic plus 400 of span, that's 600 gig going to the fab. And that's obviously not going to work. You have a 400 gig capacity on the chip and the link to the fabric, you're sending 600 gig. So there's definitely going to be a massive amount of packet drops, and this is not recommended config. In this case, if you have to do such a heavy replication, it would be better to split the ports and maybe have port 1 terminated on a different NPU like NPU 1. And so now each of those NPUs can be sourcing 200 gig of original traffic, user traffic, plus 200 gig of fan traffic. And that can go to NPU 4 and reach the analyzers just fine. So that's basically one way of figuring out how it is not just the user traffic that counts, but also the amount of traffic that's going over the fabric for packets that are being replicated. And you have to add all this together to really know whether this is going to work or not, and if you're getting overloaded, how to basically split that traffic across different NPUs. So now we can definitely knock off the how to optimally design span on an ASR 9000 task that you had in your to-do list. So just to recap, we went over the different types of span, from pseudo-wire span to local span and everything in between. We basically answered the main question, right? Which port do I connect my network analyzer to get the best performance? And how do I know whether my box can handle the kind of performance of port mirroring, the kind of load that I'm going to give when I enable mirroring on the ASR 9000 running 5th gen hardware? And I hope this video was helpful to you. Thanks for watching.